I want to present to you how we use operations research in the Audi supply chain. At first, I want to present to you the Audi supply chain team and give you some knowledge about the quantities we are talking here inside the supply chain. As you can see, we as a supply chain team, we plan, steer and move at and for 7 sizes worldwide. As you can see here depicted on the map, we have the red locations that are locations we're actually producing in. Then we have the blue location that are factories where they do the final assembly. What I mean by this, we already assembled a car to a certain level at the red dotted locations, then transport it there, and then at the final blue locations, the final assembly is done. This is due to taxes or some country laws or restriction. For example, in the Chinese market, we just deliver there the already assembled parts and then the cars there get fully assembled. Lastly, you can see the 3 black dots, where we do the packaging and the shipment. To give you some characteristical values, within the inbound, we move every day 1,500 trucks on the street and 100 wagons on the trails. We do 1.2 million commissioning parts every day. In total, we transfer 150,000 containers every day. We ship a volume of 4,500 cubic meters every day. That is a shipment that goes to the blue locations in order to fully assemble the cars there. We have a total logistics area of 1.5 million square meters, and we have 4,000 external service providers that help us running our supply chain. I myself working at the so-called Smart Decisions team in Audi. We are quite a small team. We are just 5 members consisting of mathematicians and engineers. And we focus, or our goal or task is to use operation research in order to improve the supply chain regarding costs, resilience, and carbon emissions. Like this? Okay. I see. Okay. We do this in some kind of full fashion, a full stack fashion. What I mean by this, we cover the whole procedure. So we talk to our responding colleagues or expert. We do the mathematical formulation. We do the implementation in Python. And finally, we develop software with a GUI so our colleagues can, or that enables our colleagues to use the software on their own. We did this so far for over 30 projects within the supply chain. And today I want to present to you one quite recent project, which is optimizing the delivery frequency. At first, I want to give you a short introduction what the problem of selecting the delivery frequency is. Then I want to give you on a high level some insights into the mathematical model. And finally, I want to tell you what we were able to achieve by using operations research in that kind of problem. So at first, what is a delivery frequency? Basically, it's the question when you want to get your goods delivered. So like, for example, every day or every second Friday. This problem is already quite well known. It's also represented in the classical economic order quantities. So what you can see basically here, you can either choose a high frequency, which means, for example, please deliver my goods every day, which results in quite high transportation costs, but you basically have no inventory costs because you get your parts delivered just in time. On the other extreme, you can choose a really low frequency, which means, for example, just deliver my goods once a week, but then the whole demand for 1 week arrives at 1 day, and you need to store the whole weekly demand in your inventory. So basically you have the dilemma between the transportation cost and the inventory cost, and you want to find the sweet spot where the combined cost is minimal. In Audi, we have 2 concepts. One is the direct deliveries, where the supplier directly delivers the goods to the factory, and the other one is the cross-docking. At cross-docking, the supplier first delivers it to a cross-dock, and then from the cross-dock it goes into the different factories. You can imagine this like in Eastern Europe, we have a lot of suppliers, and we don't want to deliver them directly to our factories, so we have cross-docks there, and all the stuff gets bundled there and then transported to the different factories. Considering direct deliveries is a quite easy task because you basically just need to solve the economic quantity orders, and this is already done by the software we are using, so there were no big potential. But at the moment, we do not consider any cross stocks. Considering cross stocks is more complicated, but we found a high potential there. So it basically comes down, if you look to the picture, we have here a supplier which delivers to two different factories. And when you manage to synchronize the delivery such that this delivery to the cross-dock happens at the same day, you can just get lower transportation costs by bundling it up there. So the first question that comes into mind, how to handle the cross-docks, is to naively add up the two economic quantity orders, but that unfortunately does not work. Why is this? The inventory cost you can just add up, that's really easy, but the transportation cost is sub-additive. As I already mentioned, when you manage to synchronize it that this transportation here happens simultaneously, it's just cheaper than adding up the pure values. So basically, as I already said, we need to synchronize it. When the supplier delivers both the blue and yellow goods at the same day, we can just sum it up. And when we have a look at the transportation costs, you can just see here the transportation costs for the orange good and the transportation goods costs for the blue goods. And there would be a linear equation, then it would add up to like this. But the real underlying transportation cost is a digressive sub-additive function, which means just like basically it's every time less than just adding the pure numbers. So that was it. Unfortunately not. We also need to consider some other complications arising at this problem. So there's one is the delivery and the inventory restriction. Basically, our colleagues at the docks are not able to unload an unlimited amount of goods per day. So we can just unpack a certain amount. And the other restriction is just the inventory. I mean, our inventory has a certain size, so we cannot just tell every supplier just deliver once a week, because then our inventory would overflow. So we also need to consider those two constraints.
Is there a buffer at the cross-dock?
Yeah, there is a buffer, but we do not consider it because basically the cross-dock is really cheap cost, because there every day goes a truck and everything gets bundled. So what we are basically considering is just the cost from the supplier to the cross-dock, the delivery, because on the delivery from the cross-dock to the factory, we cannot change much, and there's not much potential there because we have really cheap contracts because we do it on a daily basis. And also we need to track the deliveries and the arrival at both dates. For example, here we need to check when the supplier delivers in order to combine the transportation costs, and on the other side we need to keep track of the actual arrival at the factories, because here we have our inventory and delivery constraints we need to consider. So, and how can we model that? We basically, there's a lot of literature regarding the topic. The first one is from over 100 years ago. There, Harris wrote the already presented economic order quantities, which I showed to you. Then 16 years later, there was this important paper by Under. So in the German-speaking area, you also know this as the Under formula. But as you can see, there's also quite recent research to the topic. There it gets more specific, where you consider different loads, loading of trucks, and also the container circulation. So the empty containers also need to go back to the supplier. And we focused on 3 aspects in modeling this. First, we did the basic model formulation. Then we integrated our cross-docking concept. And finally, we need to find a way to approximate the unknown transportation cost, because as we saw, we cannot just add it up. We needed to some way to calculate the transportation cost. So now bringing it into a mathematical framework, we have the target of One, minimizing the direct transfer cost or transportation cost. Secondly, minimizing the shared transportation to the cross-dock. And finally, minimizing the inventory cost. The decision variables or degrees of freedom we had during this process was to choose the delivery scheme, so when each supplier should deliver their goods, and also which volume should be transported from the cross-dock to the factories. And our constraints, as already mentioned, was the limit on the delivery, the limit on the inventory, and the obvious one that for each supplier, a delivery scheme must be chosen. Okay, and don't be afraid, you don't need to remember this by heart, it's just for the sake of completeness. I just go over the first 5 ones. So T was the list of all days, S was the set of suppliers, capital F was the set of all factories, and then we have the set of all delivery factories per supplier, and capital D is basically the set of possible delivery schemes you can choose for each supplier to deliver to a factory. And then we did our formulation. We have the decision variables, so which delivery scheme should be chosen and which volume should be transported from the cross-dock to the factories. And that gives us our objective or target function in the end. We have, like, for each supplier and each factory, we have the transportation cost based on the volume which is transported, plus the sum of the chosen delivery schemes, which determines then the inventory. This function we wanted to minimize. Modeling our constraints, we have the first one. This ensures that exactly one delivery scheme is chosen per supplier. We have the second constraint, which just sets the volume to its certain value. The third constraint, which ensures that the limit of the deliveries per factory is ensured, and the last one, which just models the inventory per factory. So the last missing part was how to get the sub-additive cost function. This was quite tricky because the cost function is done by a lot of contracts and is dependent which countries are passed during the process, and we were not able to derive directly the function. So what we did there was basically we queried our transportation cost calculator with equidistant grid points to get a discretization of the cost function, as you can see on the left side. Then we did a linear interpolation, and finally, to get rid of some grid points, we just did an approximation by another piecewise linear function to get less grid points in order to bump up model performance. Gurobi already has a nice API for implementing piecewise linear function and also an internal piecewise linear function solver. But unfortunately, the model performance was quite bad. As you can see on the left side, we had still a gap of 100% after 90 minutes, and the optimizer gets stuck by neither could he minimize further the objective function nor bump up the lower bound. So we asked the Gurobi support team for help, and they give us a nice hint. Instead of modeling it inside the model with a piecewise linear function, we just added it at the end to the objective. This helped on the one hand the pre-solver to do a better work, and on the other hand internally the optimizer knew by itself to apply the piecewise linear solver. So this trick helped us to immensely speed up the model. So like after 90 minutes we were able to get the gap to 2%, and we were shortly converging. Finally, I want to give you some model statistic. Our whole model had like 140,000 columns and 150,000 rows, so it was quite large. The matrix had over 10 million non-zero entries, and we run the whole stuff with Gurobi 10.1, and we did it on our virtual machine which has an 8-core CPU with 2.7 gigahertz. So after 10 minutes we were ready to get a 5% gap, and now the question is, what were we able to achieve by doing all the stuff and operations research? And we got quite a nice result. So with the provided solution, the inventory cost more or less just stayed the same, but we were able to reduce our transportation cost by 20 to 30% in this case. And here is some more literature we used. And actually, I think I was quite fast. But thank you for your attention.
The reduction of the transportation cost,
Yeah.
is it compared to the non-crossdock solution, or is it compared to the manual crossdock solution?
To the manual crossdock solution. So we had like the planning, I mean, we run this procedure like for over 20 years, and we were just able by the software to consider the direct deliveries and optimize it, but there was no one considering like synchronizing it with the crossdocks, because on the one hand it's really complicated because you need to get different factories on board. Then just it adds up, and in this case we did it for Ingolstadt and Neckarsulm, which are more or less our biggest factories in Germany, and just for these two factories we were able to lower the transportation cost by 28%.
Great, thank you.
You're welcome.
Nice, thank you. Did you treat all inventory types the same? Because you may know, okay, this approach of the ABCXYZ matrix, so fast moving versus value.
Yeah.
So the Z type of inventory obviously is not worth a lot, yet an AX, okay, is the strategic one.
Yeah.
I couldn't see, okay, whether you treated those the same.
So when we have these high moving parts, we basically have in Ingolstadt, for example, really near the factory and inventory stuff, and there it gets commissioned, so picked, and then it gets delivered just in sequence. This one we did not consider. So basically the one you saw here were like the slower moving parts.
Thank you.
Hi. What kind of risk you did not take into account of the model?
By risk, you mean like?
Transportation delays, traffic jams.
I need to say that we did not consider any kinds of risk, because in the current situation it's also not considered, and all the transportation is done with a security inventory, so this we kept. So it's, I think, like 10 days we can capture delivery delays without any stop of production, and after that, depending on the part, it gets critical.
Did you also consider load carriers? So you have all the empties stacking up in Ingolstadt, and did you also consider that, how to get rid of those?
We actually did, but there the optimization did not have much potential, because this is already quite optimized.
I was thinking of an integrated optimization, so that when setting up the delivery profile at the transportation mode, is it like, or was it observed that load containers are kind of a problem, or is it just?
No, basically not, because as you have seen, the inventory more or less stayed the same. So what we did is just shifted the delivery schemes and reordered them in a new fashion, but basically the container circulation more or less also stayed the same as before.
So the transportation mode for relations stayed more or less the same, so either direct delivery or area shipping? Or did you also decide which suppliers get direct delivery, what else get a milk run, or what?
No, this was already predefined, so we left it like this.
Okay.
That's also due to contracts, because we already have a contract with the supplier which says you just need to deliver to this cross-dock, and we were not able to change anything right there.
Yeah, we did it a different way, but yeah, interesting.
And have you considered to add something like strategic inventory cost? What I mean with that, like last year with all the problem with semiconductors,
Yeah.
that once the problem with supply is critical, then it may include more losses than for example, savings on inventories.
We did this, but we did this on a different project, but not considering in this kind of optimization.
Did you consider constraints from the factories? Like, do you have to ship a full truck to the cross-dock or to your factories, or doesn't it matter how much is on the truck? So did you have like constraints from the factories that you had to take into account?
You mean the load level of the trucks, or?
Yeah, exactly. How much
Yeah, we
factory
just
produces?
captured that by the delivery constraint. So we said like per day we can just have a certain amount of goods which our colleagues can unpack and put into the inventory. But so it's not, I mean, if you have 2 half-loaded trucks, it's the same volume as in 1 truck. So for the delivery constraint, it's just the total volume that arrives at the date.
Yeah, I'm wondering if you have the mixed situation that for the same supplier or factory, you have one for some inventory you ship directly, and for some the other you ship cross-docking.
Sorry, can you repeat? I didn't get the question in the
I mean,
beginning.
for fast mover inventories, do you
Yeah.
ship for the same article, same supplier or factory, you ship directly, or for the slow mover you ship cross-docking? I mean, do you have the mixed situation for the delivery?
We just have the mix for really special parts, but basically if it's directly delivered or to a cross-dock depends on either how far the supplier is away and if we have a cross-dock there. For example, we have 2 in Eastern Europe. That's quite nice, but I'm not 100% sure, but as far as I know, we have nothing for when something comes from Spain. So we have no cross-docking in France, for example. So there's not even the option of cross-docking. There's just a direct delivery. But I'm not 100% sure about this.
All right, thank you.
Is your model somehow connected with the need of people for loading and unloading the trucks and also optimize this section?
This was already predefined, so we can not do stuff like this, and also like shifting employees and stuff like this is really critical. So we didn't want to touch that aspect inside this optimization because it really gets political quite fast.
May I ask, how do you use the Gurobi software? Like, if you, as far as I understood, you have multiple optimization projects in the company, and I assume you use Gurobi in multiple projects.
Sure. Basically, we do it like this. Since we often use systems within the VW group, VW group, we cannot easily integrate it because integrating it means integrating it over all brands. So basically, the approach we use is we develop software, and then we load it up to our server, and we provide to the user some kind of graphical user interface. They can upload their Excel sheets or their SAP sheets, whatever they use. And then we put it on the server, and there runs a cron job, which basically checks like every minute, is there a new request? And if so, we optimize it on our side, on the server with an unlimited license. And then after running the optimization, we deploy the results back to the customer, which is then an Excel sheet or a Gantt chart or whatever kind they use.
So you use this Gurobi compute server or cluster manager?
We want to change to this because we also combine it with other departments which use Gurobi. But at the moment, our 5-people team has its own unlimited license, and we run it just on our own Linux server there. Yeah. So it basically takes some time. If you have 5 requests, they just get done in queue. So sometimes you have to wait, but we don't have much live stuff. Basically, it's not critical. If it's done within 2 hours, it's fine. It's not like on the spot.
Okay, thank you.
I remember that you mentioned that 20-30% reduction on the transportation cost. I assume it's like the opportunity cost that is missing there, like 20-30%, like theoretical impact. Have you measured the realized impact once you implemented this solution? Like, is there deviation between the expectations?
Yeah, I see. Basically, it's a quite new project, so we are just in the implementing phase, but the savings we get from the transportation cost is also under the requirement just shifting 15 suppliers. So we didn't come up with a solution where we said you need to reorder everything because this is practically not possible. We just said you are just allowed to take 15 suppliers, and our operating colleagues just said changing 15 suppliers within 3 months is possible. So we are just realizing it, but we are quite optimistic that this will also be like the effective stuff.
Did you take also the aggregation in the crosstalk into account? So let's say we have 2 factories coming from the east, both should deliver to the crosstalk, and then you would have 4 trucks outgoing. If you wouldn't aggregate, for example, do you also then do an aggregation in the crosstalk that you kind of just send 2 in, 2 out, basically, if the volume obviously allows it, or didn't you?
You mean like a bundling?
Yeah.
Yeah, we do a bundling. So for example, when we have a supplier for wheels and another supplier produces another part, they both send it to the crossdock, and then 1 truck to Ingolstadt gets bundled up if it's both full, half full trucks, basically.
Okay, thanks.